basic trig, it's essential really that we understand how to label a triangle, a right triangle. Trig is all about sort of comparing the sides of triangles, and we come up with our well-known SOHCAHTOA, where these are the trig relationships. These are the trig ratios. We know them well. Sine theta is going to be, let's do this, color code this just to try and make it easier. Opposite over hypotenuse. Just use HYP for hypotenuse, and op for opposite. Cosine theta, well, that's going to be the adjacent side, ADJ, we'll say, over hypotenuse. Stop these rolling around. And the last one is going to be tan theta. And this is going to be the opposite side, going for adjacent over the adjacent side. So these are the trig ratios, and they're all based on these ideas of opposite sides, adjacent sides, and hypotenuse. So the most common mistake for students just starting trigonometry is either not to understand what these mean, or simply to muddle them up and get them wrong. So it's quite important that we get some idea of what these mean. So let's just sketch a couple of some triangles. Let's sketch one that looks like this for a start. Here, right-angled triangle. So we're dealing with right-angled trigonometry at the moment. And let's say that this is the angle which we're interested in. These sides are all going to be relative to this angle, where this angle is. So this is the confusion, that as we move this angle, say, and we become interested in here, all of these change. So we use theta. This is theta, the Greek letter. We use theta really as a sort of a variable for angles. So you see theta, and it's a bit like x in an equation, and you just always see it in triangles or something to do with trigonometry. So we'll refer to theta, Greek letter there. Now, what are the opposite, hypotenuse, adjacent, and so on sides in this triangle? Relative to theta. So, well, the first one is the easy one, and that is going to be the hypotenuse. Hypotenuse, quite simply, is opposite the right angle. This is 90 degrees. So the hypotenuse is opposite the right angle. So it's opposite the 90 degrees. It's also easy peasy to see the longest of the sides. So the hypotenuse is fairly straightforward to see. And the hypotenuse is not relative to theta. It's relative to the 90 degrees. So theta is never the 90 degrees. This is always the right angle here. It's always the 90 degrees, always the right angle, and the hypotenuse relates to that right angle. Our opposite and our adjacent are relative to this angle here. So the opposite, again, is simply opposite it. Go clean across the triangle, and here we have our opposite side, and it's opposite to theta. It's relative to theta. So this one here is now going to be the adjacent side. Adjacent. And the adjacent side is always one side of this theta. It's next to theta. Adjacent means next to. One I like, it cozying up. It cozying up to theta. I like cozying up because look, COS, cosine. Cosine is adjacent over hypotenuse. Cozying up, adjacent. So the adjacent side is always touches. It touches our angle. It touches theta. It is a ray, one of the rays of theta. It's one of the rays of the angle. So what's really important is that students get this. Now, of course, the problem is that triangles change. So let's draw a few triangles here. Right angle. Let's say that's theta in this one. Let's do another one here. Let's say theta is that angle. Theta is that angle. There's the right angle. Let's draw another triangle here. And we'll say that theta's that angle. Tip one up a bit. Let's do a right angle like that. Right angle here. And let's say theta's this one. So the opposites in all of these are changing. So here's the opposite to this one. That's O. Here's the opposite to this one. O. This one will come across the triangle. O. Across the triangle. O. They're all of these are opposites. Opposite sides to theta. Now the adjacent side is the hypotenuse. Best label the hypotenuse probably, let's label the hypotenuse sooner rather than later, because it really, get it out of the way. It's the one that's clearest to label because it's opposite the right angle. This is the hypotenuse. 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 Now there's only one left, but it is the one that forms the other ray to the hypotenuse. This is the adjacent. Runs down the side of theta, adjacent. Runs down the side of theta here, adjacent, forming the angle with the hypotenuse. The angle between the hypotenuse and the adjacent is going to be our angle theta. Again, A. So this is undoubtedly the most common mistake that students in their early stages of studying trigonometry make. You see that they mislabel the sides, or they don't label them at all, and then they try and do these trigonometric ratios without labeling the sides. So the absolute sort of golden rule is, I don't have gold here, I just have some of these colours. Golden rule, or let's say key rule. Key rule, always, without fail, label your triangles. Then things become lemon